Most of you were in my last class on multivariable calculus, I hope. Please, can you respond in the chat if just to be sure? Were you in the same multivariable calculus class? Because I'm assuming that you have gone through that. So okay, I can see two responses there. So that means that you have an idea of the way I teach and the way I examine, and some of those things are clear to you. So that's good. This time we're going to follow a book much more consistently than we did in the multivariable mathematics, multivariable calculus. There is a textbook. The title of the textbook is Continuum Mechanics for Modeling, Simulation, and Design by O.A. Fakilede. And that is the cover page of the book that you can see on the screen. That book is available for downloading for free to UNILAG students. So you don't you don't spend any resources apart from your data on your internet to be able to get the book. So we are going to follow in it, but I'll explain to you how we shall follow it. Much of the contents of chapter 1 of the book is already covered in your multivariable calculus course of last term. Not all, not everything is covered, and I will explain to you how we will deal with things that were not covered in the multivariable calculus. But regardless, I'm starting to teach from chapter 2. I will be ready to review any topic in chapter 1 that is problematic to most people. I will do slides and I will give a video. I will teach that. I can also teach a topic based on a request from the class. Let us say the class believes that, well, look, we don't understand enough of this particular thing. Sir, can you go over it again? I can take that topic again and do fresh slides. If we don't do that, so the first 5 weeks is as if we have gained 5 weeks for this course. So that's why I'm starting from chapter 2. So if there is any reason why chapter 2 is hard, and it is likely going to be related to your not understanding or not following something in chapter 1, or it's difficult for you, I will be ready to give you a makeup for that. But that request must come from your class rep as a representation of what the class feels. I'm not going to take it one by one. You meet, talk to your class rep, let your class rep tell me that that is what you have. Please, admin, find a way to send a message to the class rep, to the carryover students. The way people fail is by not attending classes and not starting their self-test on time to know where they are. I do not care whether you're a carryover student or not. My only duty is to instruct on this course and give you the grades you deserve at the end of the term. I don't deal with carryover students differently from the way I deal with other students. So the fact that you are a carryover student does not entitle you to an easier passage. The reason why you are carrying over was that you didn't do it well the other time. If you don't do it well again, you just fail again. That's how simple it is. So I hope carryover students don't just give me that bull that you are a carryover student, therefore you will pass. If you think so, you will see at the end of the term whether that is true or not. But by that time, it may be too late. So I'm starting to teach from chapter 2 today. As I said, I will review any topic in chapter 1 that is problematic to most people as presented by the class rep. I can do a review also by request from the class. So even if the topic is not problematic and the class really, really wants a review, I'm willing to review on just that basis. The materials here are better developed than what I gave you in multivariable calculus last term. I will take a look at some of the differences so that you can benefit more from what you are being given. It's important for you to note that all chapters of this book have Q&As. There is a question and answer section that contains full questions and complete answers. They are not objectives. They are full question and a full development of the answers. So you are supposed to review all of that. The questions in the database of the self-tester are mostly paraphrases of the same Q&A. It's the same questions in the Q&A that we are bringing up in an objective form. So those questions are essentially saying the same thing. So if somebody can solve the objective question or solve the full question, they are essentially the same. So if you fail an objective question, we have written the code in such a way that the computer will tell you what particular, that question you have failed, what Q&A was it based on. That is to help you to go and review that Q&A so that next time, if that question comes up again, you can do it well. When you do a self-test, apart from giving you your result, we also give you with the Q&A or theory, we also supply you with the Q&A or theory that forms the base of the questions you have missed. This answers the request of some students that we could work out the solutions to these problems. Last time, some students requested that, well, look, if I miss a question, how can you work it out for me? The way we work it out for you is that we refer you to the Q&A that form the basis of the question. So if you can study that Q&A, you should be able to answer that question next time you encounter it. This arrangement is better developed here than last time. The work on continuum mechanics is something I've done for a much longer period, and I've carried it further than the work on the multivariable calculus, which I only started last year. So this thing takes time. Make use of this to do your review and corrections. More notes. Sometimes the question in the self-test comes from the textbook directly. In such a case, you are to read the pages specified in the text to find solutions. So your report from your exam can either point you to a Q&A or point you to a particular page in the textbook or point you to a particular slide in a tutorial class. So sometimes I give you tutorial classes and the Q&A is based on the tutorial class, on the question in the tutorial class. So wherever the question came from, we will locate most questions and tell you where they came from so that you can go and study those things and therefore not fail the question when you see that question in next time. The mathematical programs written to solve some of these problems are sometimes given in the text. So they can help to improve your mathematical coding. Try this on your own. You should have Mathematica installed on your computer to help you in this course. Self-test. Let me send the question to the class, and I want answers in the chat. Now, as a group of people, do you think the self-testing system we are using is useful to you? I want your answers, because we allow you to do self-test through the term, and then do you think it's useful, the self-testing? Then some people say it's okay. Okay, very much so. Okay, so if it is, then we are going to continue. We are going to continue with it this time. So it should. So if you want to get an A in this course, I'm sure you know what to do. I'm sure you know it is not hard to get an A in this course because it's going to go the same way as before. Do your self-test over and over. I expect you in the course of the term to at least do 10 self-tests, at least 10. There are people who did only one self-test. So if the final mark on the self-test or on the continuous assessment is 40, and you got 20/30 in the self-test, and you only went once, I will give you 1 extra mark and it will become 21 over 40. But let us say you did the self-test 10 times and you got 20 over 30 average. I'm going to add 10 marks to you. So it will now become that your 20 over 30 will now become 30 over 40 because you are going to be given you are given 1 free mark for every attempt as the self-test. So you can see it's better for you to go to do the self-test over and over. And I'm sure by the time you do more self-tests, you'll find that your ability is increasing. So that is the reason for that. That's how we did it last time. I am not guaranteeing that that's exactly how it will be done this time, but you can be sure that something similar to what we did last time will be done again. So I just want you to bear that in mind. So so you can start your self-test once you are given access. Start from chapter 1. Let me know which topics there you will need to review. It is good to see the book in one whole. It will be beneficial to look at things this way. The reason why there's a lot of similarity with your multivariable calculus is because I want to be sure that students do not suffer unnecessarily from weaknesses in the beginner courses. So if I want to teach continuum mechanics requires tensor analysis. Tensor analysis requires vector and coordinate geometry. I could start by assuming you already know vectors. I have done that before, and I found out that people continue to have problems with their tensors, not because the tensors were hard, but because their vectors were weak. So that's why you see the similarities you see. Most of those topics are supposed to be in the multivariable calculus, but they are brought here just to be sure you know them and you are not going to suffer because of your poor knowledge of them. That's the reason. So when you see weakness, when you see repetitions, take that as for emphasis. We are sure you need this thing. That's why we're emphasizing it over and over again. So don't get bored. And some of you may find out that your vectors were better. You will even know more of those vectors now than when you took them at first. So it might be, the repetition might have be helpful to some students. I don't know. Experience shows its own counterproductive to just move on and assume you know some of these things. So that's why we are spending the time. I think with that preamble, I just want to go to the first lecture, which will be equivalent to week 6 in the published version of this course. We are in week 6. So like I said, we will be willing to go backwards and give you some more lecture or some more instruction on the previous work as you wanted.